Alright, so here's our primitive data. If it's not an object, it's going to be primitive data. Our different types, oops, I didn't want to click on that. There are 8 primitive types in Java that we don't have to worry about all of them. We have 4 for integers, byte, short, int, long. We have 2 floating point numbers or decimals, float and double. We have the character, and then we have our Boolean values. For the AP exam, all we're really worried about is int, double, and Boolean. And it doesn't really matter. We're not going to be tested on this, but we have a float versus double. We have a 32-bit floating point number, and then we have a 64-bit floating point number. And keep in mind that this is not twice as big. So 32 bits versus 64 bits, right? That's not twice the storage. 33 bits would double your values. So we look at the maximum and minimum values here for a double, right? It's much larger than an int. So in int, you're going to basically be capped at plus or minus 2 billion, and then I give 10 to the 308th power for your 64 bits. Your 64-bit value. And so it's not as big a deal now as it maybe used to be, but memory management of declaring things to be size bytes if you needed them when you had very small mobile devices back in the 90s was a bigger deal than it is now with the storage capacity. But they still exist, and you'll see them in different capacities. But for us, int, double, and Boolean are what we need to know. Again, our Boolean values, we've used them before, true or false, that we can use for those. Characters store a single character Unicode set, so sometimes they're useful. For the most part, we're going to avoid them, but it's basically in an ordered list, and it has a number attached to it, and then you have these character literals, just like a string literal, but we have single quotes around them that we can use. And then we have the ability to add and subtract, multiply, divide these values, and then take the remainder. That's our modulo piece. So that's really the one that we have a value. One thing to be aware of is if you take 2 ints, so let's say that we have an int and the value is 4, and then we have an int val2 is 3, and you do val divided by val2, we don't have the ability to store, so we get, right, 4 over 3, which would be 1 1/3, but that 1/3 can't go anywhere because there's no storage capacity for it, so it just goes away and you're left with just the 1. So be a little bit wary of the data type as you're doing your divisions. We have our remainder, right? So 14 divided by 3, that's going to go in 4 times plus something left over. We're just going to be left with the 4. And then 8 divided by 12 is 0 point something. We're just going to be left with the 0. If we look at our remainder, right? 14 remainder 3. So this is, again, going to go in, it's going to go in 4 times remainder 2. And that's the value we're left with. And if we think about it on a number line, there's 14. I go 1, 2 spots to get to 12, which is a multiple of 3. And so there's where my 2 comes from as a modulo piece. All right, we can do 8 divided by 12, or remainder 2 as well. This is new, so this is a new topic. This is data conversion. So let's say we have values that are ints, and then we have a double, and then we have a decimal that's set to 5.3. So we're allowed to take number and set it equal to value. So we can be more precise, and that's okay. So this has the ability to basically be 0.0, and give it a value, we get 4.0. We just add that numerically, it's no different than 4. We're allowed to do that. Now if we go the other way around though, if we take our value and set it to decimal, well, decimal has this decimal attached to it, right? It has this 0.3 here. And my int doesn't have a place to put that. And so it could equal 5, but we've lost the 0.3, and the compiler won't let us do this unless we explicitly what's called cast it. So if we look at that, what that means, if we look at that, we have to cast it. So this piece here is going to be our cast. So this says it's okay to lose, right, the 0.3, and we should be left with at this point 5. So we can look at that and look at what the compiler, look at that error looks like, because that one's new. So if we pull up this file, That's not the one. Let's pull it up. Give me a moment here. Alright, here's the file I was looking for. So this has our values here. So we have the same piece there. If I uncomment this value equals decimal, you'll see what happens. I get this loss of conversion from a double to an int. So it's a possible loss, right? So if I comment it out and we look at what this will happen here, this should get set to 4.0, this should get set to 5, and we close it and run it. And there we go, 4.0 and 5. So that's it for those two sections. Go ahead and read through the book on your own, and make sure, but again, only the real new piece is your casting part here. All right, good luck.